to All Things Data Science, the one-stop channel to help anyone interested in learning or transitioning to data science just like I did. So the first series we're going to start with is the LeetCode series. Part of the agenda that we had covered before is sort of the computer science angle of things and algorithm data structures and how does that all come together. So the idea with this series is to tackle various problems from the website. It varies from easy to a little bit harder and then more hard. So we'll start step by step. And our very first problem here, so the website is called LeetCode.com, the common place to sort of train and try out these kinds of problems. Excellent platform. And we'll be talking about it a bit more, but focusing on the TwoSum problem today. So what is happening over here? So we get the problem statement and it's telling us at the very top here that we are given, as in input, an array. So let's look into that. We have some kind of array. It's an array of integers and it's called num. So we can picture some kind of set of numbers here. So we've got num as being sort of, this is the input area. And then what else are we given? We're given a target. So that's the name of the actual variable, and that's just an int type. And they give us handy dandy examples here. So this is an example of a target, and this is an example of num. Okay. And then it says what we want to get back is basically two indices. So specifically we're looking at indices here and not the actual number here. No, that's not what we want. We want the actual index related to that number. Okay. And the good thing is they're telling us that actually there is an exact solution, so there's no tricking. It's always going to be two only that are going to give us the solution. And what is the solution? It's the fact that when you add them up, these two, they're going to equate what we get for the target. Okay. And so we see it here a little bit more clearly. If the target is 6, then we go to index 0. That's not something that is gonna work out when adding up, versus for index 1 and 2, which is what we see in the solutions. Indeed, 2 plus 4 gets us 6. Okay, so how do we go about tackling this? So one idea that I find to be always helpful is thinking of sort of the simplest possible thing to do. And oftentimes I would say loops are the way to go. So this is not perfect code, but it's one way of going about things. So what is happening over here? Well, one possibility is saying, well, okay, how about I loop through my sort of given array, so sort of the input array. Great, that's one way. Is there any possibility of looping just once to potentially get an O of n? Maybe a little bit difficult because you kind of need to do some kind of summation and looking at things that are sort of subsequent. So we'll see. Maybe there is a way of doing that. So for example, one possibility that is proposed here, and that's something I wrote kind of really quickly, is how about we think about this idea of a minus. And what I mean by that is we do know our target, right? So what if I subtract that from every value here? Then that kind of gives me the answer, right? Because I'm looping through my main array, but if I know the thing that I'm missing, that's gonna be sort of that second bit here, then I'm golden. So in order to do that, let's create some kind of differentiator, sort of the minus that you get from target, and that's sort of what's happening over here, where I'm using a list comprehension, which is just a compact way of recreating an array but doing something to it. So what's happening here is I'm saying I've got my little input array. For each value in there, please take the target and minus that. So in this particular case, for example, say in here, it's going to be, 6 minus 3 is a 3, 6 minus 2 is a 4, 6 minus 4 is a 2. So that's going to become sort of what I'm calling the nums difference array. And now that I have that, well, things become a lot simpler, because I can go ahead and now start looping through that particular array that I just created. And then internally, if you're going through this, you sort of want to know, okay, if I'm looking at this particular value, then I know that that came from the difference. So what is it from my original array, but sort of skipping, however, the index you're in? What will, when adding up, give me the 6 that I'm looking for? And that's sort of what's happening over here. So to repeat, we start with the difference array, because you sort of know 9 minus the value that I've already looked for is going to give me a 3. So if only I can manage to find another 3, then I'm going to get the right answer. So we see that, for example, and that's why index 0 is not going to be in there as the output, because there's no other 3 that you could use, and they tell us that we actually cannot use the same element twice. So in this particular example, you eventually move to the second one that has index 4, and you say, if only I have if only I have a number that's 4, then that'll be perfect. And in my case, all right, I'm not going to look at my little first same index kind of position, but rather the next one. And indeed, I find a 4. I look for its index, and then basically I get to return those two. So that's one way of doing it. And of course, here we have 2 loops. I mean, the good thing with, in this particular case, for people less familiar with the O notation, generally speaking, when you are nesting loops is really sort of, you could think of going through one array once, can be thought of as O of n, meaning, you're traversing every element, even though sometimes, maybe you'll stop here. Like here we have a break. Once I do find that, yay, I do have a match over here, for example, then I'm going to stop. So great. So you're not always traversing the whole array, but when on average, let's say, really is what the notation is saying, you're going to look at every element, and that's what we call an O of n. So when you do have another for loop inside, so sort of a nested one, right? Another time that you're asking to loop through, then that's another O of n, and sort of you start looking at the whole thing as being, in this case, O of n squared. So that's okay. That's not too bad. I mean, this is a simplistic problem, and so now you need to start thinking, okay, can I do a little bit better? And then one idea, again, same thing. This is just a proposed jotted down example. And by the way, here in LeetCode, you can have a specific use case. I also wanted to try out, does this work in negative numbers? And actually, the first thing you need to say is, the nums array, is it actually even gonna have negative numbers? And we see that here they do confirm that we do. So here I was testing out, for example, one particular example with those negative numbers, but really we could have this test case where we know already the answers, we give it target as the other variable that's in our input, and then you run the code and you'll get if it's accepted or not, and indeed the outputs are sort of what you're supposed to have. So it's a good way of playing around with other use cases. So here the jotted example looks now into, all right, can I maybe avoid that nested loop so that I step away from the whole O of n squared solution. So one thing that's very common to think about in these cases is, okay, well, do I really need to loop twice? Is there something I could maybe remember or have ready at my disposal? And this is where what we call dictionaries in Python comes into play. This is one way of defining them. You could do it a little easier, and we'll look at, for example, a proposed solution that does it a little more elegantly. But again, this is really to get something working and be convinced of kind of the small improvements that are happening along the way. So what's happening here is we're saying, all right, let me, and here's something I like doing. Let me go through actually, and I'm gonna save the values that I get as my input as keys for my dictionary, and the values for the dictionary are going to be the index, because at the end of the day, that's really what I need as my output. And to showcase that, one quick thing we could do, and again, that's very handy thanks to the LeetCode platform, is you could just run code in order to look at things and see what's happening. But basically, let me see what the use case here is. So that's a little shorter. Let's do one that's sort of that original example. It's a little bit longer just to make the point of what's happening with this dictionary idea. So here I just want you to focus down here. What is going on in that first block of code? We're going through the nums and indeed saving each of those values as the key, because I'm going to remember, just like the other solution with the 2 for loops, I want to look when I have my differentiator, sort of the minus array, I want to make sure that value that I'm looking for, the 4 that was missing earlier, for example, when we did the difference, does that exist? And when it does, I want to get its index, and that's why in Python, of course, indexing starts at 0 for arrays. It's not at 1, but rather 0. So that's what we're seeing here: 0, 1, 2, 3, and really that's sort of what's happening over here. Now that that is kind of clear, we come back to the rest, and really this is the same thing as earlier. You get a for loop, and then you say, all right, I'm looking at my differentiator array, for example. Let me, in here we could do it again for extra clarity. So what's happening here, and we could try it out, for example, with the slightly shorter example, is what we did over here was we said for the nums diff array, what we get is really 6 minus 3, 3, 6 minus 2, 4, 6 minus 4, 2. And so this is sort of what this area is doing. It's looping this way, one by one. And it's going to say, all right, if only I could find a 3, but this time, instead of looking at it in another array that was sort of the nums, what it's going to do is instead look at the dictionary, L dictionary. Here is sort of what we showed. Oh, perfect. What we showed sort of over here. So here it's going to look, okay, do I happen to have a 3? Do I happen to have a 4, etc., etc.? But the difference here, at least you're not doing 2 nested loops. And finally, I do want to show full credit. So one good thing about the platform is you could look at solutions. Sometimes that's generally more so the platform solution, and they're in various languages. So just as a heads up, you're seeing a lot of Java, for instance. You may or may not have Python if that's the language of interest, but then you also have plenty of other proposals in the discussion section. So there, in this particular one, I wanted to look at the Harshig submission. And this one is really what we just discussed, but in a little shorter. So again, we're using a dictionary. And what it's doing is saying, okay, I'm going to go through, and we could look at the description again on the side, and I'm going to call it a complement. So I do my target minus the specific sort of element I have within my input array, and does it exist in my dictionary, which is sort of what we were doing earlier. You know, that one piece, the integer that I'm missing, is it already there? Because if it is, then that's exactly what I need to return. And what I mean by that is sort of you're saving, you know, the index of it. And then if it doesn't, like the example of the 3 minus 3, yes, it exists, but you're not allowed to use the same elements. So you're going to have to pick something that's different and not the current index you're in. So, and that's why, by the way, in a few of these, we're having all these little sort of a -1 to not get to the end of the array. I think in another one, I add a +1 to make sure you're actually indexing at the next piece and not looking at the same index. And really that's really it. So if it doesn't exist, then go add it in that dictionary. And that concludes our session. So please, I'd love to hear any feedback, and I'll continue more of these exercises on LeetCode. I would love for you to subscribe, and looking forward to more comments. Bye-bye.